Integration by parts usually looks like two functions inside an integration, but it's not always the case. Within this integration, you apply a formula, you simplify the formula, and that's it. So the formula is integration of u times v prime equal to uv minus integration of u prime v. So let's apply it to this question. So I will choose x. I usually choose the first one to be u and the second one to be v prime, but sometimes you have to switch. So u is equal to x and v prime is equal to cosine x. U prime, the derivative, is 1, while the integration of cosine is sine x. Now apply the formula. So uv prime, which is the question, x cosine x, equal to uv, which is x sine, minus the integration of 1 times sine, which is sine. Now, as I said, you have to simplify. You cannot keep this here. So x sine x, sine is negative cosine, negative with negative is plus cosine. And don't forget at the end to add the plus c. Next question. Feel free to choose any of these questions and the solution is on the right. Okay, so this one looks very similar to what we just did, but there's a little trick here. So u is equal to x squared, v prime is equal to cosine x. The derivative of x squared is 2x, while the integration of cosine x is sine x. Write the formula again, x squared cosine x equal to uv x squared sine x minus the integration of 2x sine x. The trick here is that inside the formula there's an integration with also two functions. So all we have to do is apply uv once more. U is equal to 2x and v prime is equal to sine x. Derivative of u is 2, while the integration of sine is negative cosine. Okay, apply the formula. And once we apply the formula, we just replace by this whole thing. We keep the negative right there, okay? So, apply the formula. uv 2x, uv prime, sorry, sine, question, is equal to negative 2x cosine minus the integration of 2 times negative cosine. Okay, we can take negative 2 here outside, and it's going to be positive 2. So negative 2x cosine x plus 2 integration of cosine. The integration of cosine is sine. So the final answer, actually not the final, cosine x plus 2 sine x. As I said, you have to replace this instead of the 2x sine x. So what's going to happen here is that I'm just going to put them beside each other. Oh, don't forget the negative. There's a negative here, right? Don't forget it. Then you write it here. And then add this whole thing here. Negative 2x cosine x plus 2 sine x. Now distribute the negative and then add the plus c and you're done. And that's it. All right, next question. X arctangent is a very interesting question. Remember when I told you that sometimes we have to switch between u and v prime? So what we usually do is u is equal to x and v prime is equal to arctangent. But when we think about it, it's really hard to find the integration of arctangent. But it's easy to find the integration of x, which is just x squared over 2. So what we're going to do is switch. U will be arctangent, while v prime will be x. Now we just have to find the derivative of arctangent from calculus 1, which is 1 plus x squared, while the integration of x is x squared over 2. Now apply the formula like usual. U v prime, arctangent of x, is equal to uv, which is x squared over 2 arctangent, minus the integration of x squared over 2 times 1 over 1 plus x squared. Okay, now you see two functions here. However, we can simplify it. You should look at the function and check if it's possible to simplify it, then simplify it. Don't do the UV once more. So let's see how can we simplify. First, we see that there's a half here, so we can take it out. And then x squared times 1. All right, let's do this. I'll just do this part right now. So 1 over 2. Remember, keep this I here, okay? The negative, keep it. So half x squared over 1 plus x squared. The difference between the top and the bottom is just that the bottom has a 1 plus. So why don't we add a 1 and subtract by 1? That way, the answer never changes. It's like saying 3 plus 1 minus 1. It's always going to be 3. Okay, so let's add the 1. Remember, the bottom should be also the same, so we can add a 1 and subtract as well. So when we add, it's going to be x squared plus 1, 1 plus x squared. This will be 1, and don't forget the minus 1, 1 plus x squared. Okay, so let's continue. 1 minus 1 plus x squared. All right, now we have to integrate each. The integration of 1 is just x, while the integration of 1 plus x squared, you should open your eyes on this one. This is arctangent, since the derivative of arctangent is 1 over 1 plus x squared. All right, now let's put this back in the formula. Just copy this here. Don't forget the negative again. Might change the answer. Okay. So just don't forget the plus c here. All right. Next question. Ln x. All right. In this question, we don't see two parts. That's why we have to multiply by 1. Now we have two parts. All right. Just do this because we cannot find the integration of ln x. If you can, then do it. So u will be ln x, while v prime will be 1. The derivative of ln x is 1 over x, while the integration of 1 is x. Okay, now apply the formula. So ln x times 1 is equal to x ln x minus the integration of x times 1 over x, which is 1. Integration of 1 is negative x, so it's going to be minus x plus c. Next question. Each question here has a different idea, so it's great to make your practice. So two functions again. U will be ex, while v prime will be sin x. So derivative of ex is same thing, and the integration of sin x is negative cosine x. Okay, now apply the formula. It's going to be ex sin x. uv, which is negative ex cosine x, minus the integration of ex, negative ex cosine x. We see again here two functions and we cannot simplify. So we apply the uv once more. So u will be negative ex, while, oh, actually, here's ex, while v prime, because the negative belongs to cosine, negative cosine x. So the derivative of ex is simply ex, while the integration of cosine, we know that cosine is sine, so it's going to be negative sine. All right, apply the formula, which is uv, uv prime first, negative ex cosine x, is equal to uv, which is negative ex sine x, minus the integration of negative ex sine x. We can remove the negative here. It's going to be plus integration of ex sine x. Okay, put this back in the formula. Let's copy the formula here, which is ex with the negative. So let's paste it here. Let's also copy this. All right, we see two negatives again. So just distribute the negative ex cosine x plus ex sine x minus ex sine x. Great. We see two functions once more. That is crazy. However, this time we can notice that these two functions here, the one on the right and on the left, are similar. And if we take it to the right, it's going to be positive, meaning that there will be two ex sine x. So it's going to be 2 ex sine x equal to negative e cosine x plus ex sine x. However, the question doesn't need two e cosines, two e x sine x. So we have to divide by 2 on both sides. And yeah, this is your answer. Ex sine x is equal to negative e cosine x plus ex sine x over 2 plus c. All right, on to the next question. Arctangent between 0 and 1. So leave this to the end and just solve for arctangent for now. We see only one function, so multiply by 1 and you're going to have 2. So u is arctangent while v prime is equal to 1. Now the derivative of arctangent is 1 over 1 plus x squared, while the integration of 1 is x. Apply the formula, it's going to be the question, equal to uv x arctangent minus the integration of x times x over 1 plus x squared. This does not seem like it can be simplified, but actually if you choose 1 plus x squared to be u and use substitution, 1 plus x squared, you can actually cancel the x. So du is equal to 2x and dx is equal to 1 over 2x. And now we can cancel the x. So let's apply it. Let's take this here. It's going to be x over u times 1 over 2x. Cancel the x's. Take 1 over 2 outside. It's going to be 1 over u. And integration of 1 over u is ln u. And let's change u now because we are at the end of the question. Add the half. And then don't forget the arctangent minus. Okay? X arctangent minus. Now, apply the 0 and 1. And you're going to find a number of 0.4 something. All right. Next question is proving that sin n is equal to this. Let's have some space. All right. So write your question, sin n of x. Okay. So first I can see in the proving that there's n minus 1, meaning that they split sin n into 2. Sin n minus 1 times sin. And this is exactly the same as sin n, because when we multiply the same function, we add the powers. And n minus 1 plus 1, there's a 1 here, is equal to n, which is sin n. All right, so now we apply the formula, which is u is equal to sin n minus 1, and v prime is equal to sin. Now the derivative of sin n minus 1 is we take the power down, so n minus 1 times sine, then the power minus 1, which is n minus 1 minus 1, n minus 2, times the derivative of sine, which is cosine. Let's make this smaller to make some space. Okay, and the integration of sine is simply negative cosine. So apply the formula, which is uv prime sine n actually, because sine n minus 1 times sine is sine n, is equal to uv, which is negative cosine sine n minus 1, so this multiply here, and minus the integration of u prime times v, which is n minus 1 times sine n minus 2, make some space, times cosine minus cosine. All right. Let me make this a little bigger. Remember, this is multiplication. So multiplying by negative cosine. All right, so we have cosine times cosine. We have negative here, so we can take it out. Let's take the negative first. It's going to be positive, and n minus 1 is a constant. Okay, so we can take it out. Let's take a number. Okay, so n minus 1 goes out. N minus 1. The integration of sine n minus 2 and cosine times cosine is cosine squared. All right, put everything back here. Equal to sine n. All right, so what do we have here? We have cosine squared, which can be also turned to 1 minus sine squared. All right, so let's do that. So it's going to be the same thing. Let me just copy the whole thing then. But with cosine squared to be 1 minus sine squared. All right, so cosine squared becomes times 1 minus sine squared. Now let's distribute sine n minus 2 times sine squared with like this. Yeah. So sine minus 2 times 1, sine minus 2 times sine n squared, sine squared. So what's going to happen is that sine n minus 2 times 1 is just sine n minus 2. Well, sine n minus 2 times negative sine squared, first negative, then sine times sine, these are two same functions, so the powers will be added. So n minus 2 plus 2 is just n. So the answer will be sine n. All right, let's write everything back. This is important when we prove. Times sine n minus 1 equal to sine n. Okay, now we can take integration of each function. So integration of sine n minus 2 and integration of negative sine n. But remember to add n minus 1 to each. So what's going to happen is that plus n minus 1 integration of sine n minus 2, same as above, but this time we're going to distribute the integration. So it's going to be minus n minus 1, don't forget it, integration of sine n. Now write everything back. Keep doing that. We can write at the end as well, but to not be messy, I'm writing now sine n. All right. So now we can see that there's on the right sine n, and on the left as well there's sine n. But the problem is n minus 1. But let's take it to the other side. So it's going to be sine n. There's a negative here, so it's going to be positive. So plus, remember, if this is positive, you cannot move it to the left. Okay, so it's because it's going to cancel. It won't work. So plus n minus 1 sine n. All right, here we can add the n minus 1 with the 1 that's here. It's hidden. We don't write the 1. So n minus 1 plus 1. It's like saying sine n, the whole thing is 1, right? This is also 1 with n minus 1. Okay, so just add n minus 1 with 1. So it's going to be n minus 1 plus 1 is just n sine n equal to the whole function again. Let me just copy it. Move it to the left, to the right here. Okay, so the question asks for sine n and not n sine n. So divide by n both sides. And we have negative 1 over n cosine times sine n minus 1 plus n minus 1 over n sine n minus 2. And this is your final answer. All right, next question is finding ln x squared over x cubed between 2 and 1. But we'll leave that till the end. So first we split it into 2. So we have u is equal to ln x squared, and we have v prime is equal to x cubed. The derivative of ln x is 2 ln x times ln x, since it's inside, 1 over x. And the integration of 1 over x cubed, what I usually do is I take x cubed to the top. It's going to be x negative 3. And then we add plus 1 over negative 3 plus 1. So it's going to be negative 1 over 2x squared. All right, so now we apply the formula, which is uv. So ln x squared over, there's negative 2x squared minus the integration of 2 ln x times 1 over x times negative 1 over 2x squared. Since there's a negative, we can take it outside. The whole thing is a multiplication. So plus, and then we have to simplify as much as we can. So 1 over x times 1 over 2x squared is just 2x cubed. So cubed here. We see 2 and 2 ln x. Hold on, let me make them closer. So 2 and 2 we can cancel it. So let's just erase it here. Ln x 1 over x cubed. Okay, we cannot simplify anymore. So this we need to do uv once more. So we have to leave this till the end. So I'll change its color so I can remember. Bright blue. Okay. So let's apply uv to this one. So u will be ln x, while v prime will be 1 over x cubed. The derivative of ln x is 1 over x, while we did this before. Integration of 1 over x cubed is negative 1 over 2x squared. All right, so apply the formula. Ln x negative 1 over 2x cubed is going to be ln x 1 over 2x squared minus the integration of 1 over x times negative 1 over 2x squared. There's a negative here, so we can take it outside. It's going to be positive. 1 over x times 1 over 2x squared, x cubed. Okay, let me make this closer. Okay, and then we can take 1 over 2 outside since it's a constant. So we take it outside, 1 over 2, 1 over 2, then integration of 1 over x cubed. 1 over x cubed is just negative 1 over 2x squared. So 1 over 2 times negative 1 over 2x cubed is just negative 1 over 4x squared. So let's take this down. It's going to be ln x negative 2x squared minus 1 over 4x squared. Let's not forget the one we left behind in the bright blue. So let me copy this and put it beside it. Let's simplify once more, just so we can put it between between 1 and 2. Okay, so let's see what we can simplify. We have 2x squared, so we can join these. It's going to be negative ln x squared plus, I took this negative outside, so I took both of these negatives outside. So ln x over 2x squared minus 1 over 4x squared. Now between 2 and 1, so 2 will give you 0.2 something and minus, and 1 will be also negative, so plus 0.25 is going to be 0.04 something. All right, stick till the end so I can explain to you when do we use integration and uv. All right, so let's say there's a bridge that there's water running under. And there's a boat that's coming. We need to ensure that this boat can pass safely. And this shape is not known. It's not a hemisphere, it's not a sphere. It's an irregular shape. So we need to calculate from the beginning of the bridge till the end, A to B. And you should know the function of this shape. But usually it's not that easy. In fact, the one we just did can be considered a real engineering problem. Thank you and consider subscribing.